Okay, let's look at this final example on this page. We notice that the coefficients of x are not going to be easily eliminated, nor the y's, but with these z's, 2, 1, and 3 all go into 6, so I think that's what I'm going to want to work with. Let's turn these first, the 2 and the 1, into 2's. We've already got a 2 in the first equation. We're going to multiply the second equation through by 2 also. So the first equation becomes 4x minus y plus 2z equals 1. No change there. Second equation, 6x plus 10y minus 2z is equal to 4. Adding these together, the z's eliminate each other, and we get 10x plus 9y is equal to 5. And that'll be my first equation with only two variables in it. Now let's take the bottom two equations again, and I'm going to turn them each into 3 z's, meaning the middle equation is going to need to be multiplied through by 3. This will give me 9x plus 15y minus 3z is equal to 6. And the bottom equation sliding over gives us negative 9x minus 15y plus 3z equals 0. And you notice when you go to eliminate the z's that the y's and the x's eliminate also, and you end up getting 0 is equal to 6. That right there is trouble, and we are not going to be able to get a solution here. So either our planes that we're dealing with are parallel, or something funny is going on. We'll deal in a later section with how to handle this. But for now, we're just going to say no solution to this problem.